Almost ready? Find a seat. There's enough left. It's actually funny. There's always two people sitting here at the front. They're like the two Muppet guys. So nice. Although we have two new ones now. Okay.
Yes, always new ones.
We don't have much time.
Yeah.
So without further ado, Oscar, take it away.
Yeah, okay. Hi, I'm going to talk about data traffic. It's inside relational databases. This is me. I've been around a few times, so you may have heard about me. I'm currently doing something other than relational databases. Yes, what I'm going to talk about is I'm going to assume a few things. I'm going to assume that you know what data you have in your systems. I'm going to assume that you know what to do with it, and I'm going to assume you have a basic understanding of the SQL language. And then, whoops, a bit too fast. Okay, if you have a traffic jam inside your database, then you have a few symptoms. Your queries become slow, sluggish. Sometimes your database connection even times out. Or if someone makes a service call, that service call times out. Same problem usually. Okay, relational databases. That's the main topic. And for online transaction processing, nothing beats a relational database. I mean, they're that good. They've been in development since the 70s. They have query planners that decide exactly what to do with the query, how to look it up. PostgreSQL does a very good job of it. And that also means that the root cause of a query problem is that the database is doing too much. Okay. Databases have an explain functionality. It tells you what it is doing. And the single most important thing about that is what it tells you about costs. Costs have 4 parts. The first part is the startup cost, then the total cost, the number of rows it expects to output, and how much data it is. Less is better, usually. Then, the menu, databases can do all types of scans, joins, sorts, whatever. You can find a lot of it online. The Postgres manual does a good job of it. You don't need the specifics unless you are really interested. But what if explains tell you this? The numbers in the costs are fairly high, which means, Houston, we have a problem. So, what do? You'd like to improve this. There are 3 steps to that. Know your data, know your use cases. I said I assume that you know about that. The reason is that I cannot tell you what your data looks like. I cannot tell you how it's going to be used. Know your data. The best way to optimize queries is to design your data for reading. Usually your data is read more often than it's written anyway, so that is a good thing to do. And then, of course, it's nice to identify immutable data. I see I left the parentheses there. The next step, of course, is then to know your use cases. The first steps are related, so I'm going to skip on that. I'm going to handle them both at the same time. If you're going to query, try and limit the number of tables that you need to filter on, or even limit the number of tables that you need, period. Because if you need to look up and join less, then the database is doing less work. Less work means it's going to be faster. In the end, it can be a lot faster, especially if you can denormalize immutable data. The nice thing about this, if you can even make data immutable if appropriate. It also changes your use cases, so be friends with your PO. When you do so, you reduce the workload for your database. And this can never be stressed enough. If the database has to do less work, it is of course going to be faster. No shit, Sherlock. The last step, if you think that you have reduced all the places where you might need data from, if you have reduced all the things that you need to filter on, or at least if you centralize them in the same place, then it's time to tune your queries. That's only the 3rd step, so it's fairly easy. Also, what to do is also easy. You just create an index for every query and table pair. Yes, that might explode the number of queries, but it gives you speed in return, and storage is fairly cheap anyway. Then, of course, you're going to sort the columns inside the index, because what does the database do first? It's going to filter. A database is going to filter first for the very simple reason that if it needs to retrieve less data, it needs to process less data, and it's going to be faster. Then, of course, group bys, because if you're doing stuff with data and you need to group it, then it's there. And last part of an index, if appropriate, therefore if you have somewhat larger result sets, are columns to sort by. But still, you want to have smaller indexes where possible because they perform better. Usually an index is a B tree. That means this is the size of each block, and the more fits in there, the faster your index works. Also, if you have a huge amount of indices, it will degrade write performance. So limit the number of queries if you can. That automatically drastically reduces the number of indices. Okay, I think I'm very well on time here. So who thinks I'm babbling? Nobody? Oh dear. I'm making sense. Thank you. At least one. There was a quickie, so I'll go to the takeaway. The best way to optimize queries is to do less. It may be a no-brainer, but it's actually quite difficult to achieve. And the only way to achieve it is to know your data and to know your use cases. In other words, if someone asks you, "What the hell are you doing?" then you have an answer. And that's it. That's all there is to it. Thank you for your attention.
I have to hand it to you. I think you're the first so far, for sure. Probably the only one that's exactly, well, before time. So we have some time for questions. Anyone having maybe a database-related question or something else for Oscar already?
Yeah, I see one.
Wait, would you, before, because we don't have a mic, would you do me the honors of showing how the catch box works? My arms are kind of sore. You basically throw it at their head.
At the question hand.
Hopefully, they'll kind of... Yes.
It's approximately
It's already
there.
on,
Yes.
I believe.
Does this work? Oh,
Yes.
God.
Yes.
What's denormalizing your immutable data?
Okay. When you're following some sort of abstract course on databases, they're going to throw stuff at you that's called normal forms of a database. There are several of them, and basically it means that for each level of normal form that you increase, you're going to ensure that data is kept where it is needed. You're going to group data by moments and points in your data where it is going to be changed. And denormalization means that you're going to copy data to the places where you're going to use it, as opposed to where they logically belong. But you can only do that if the data does not change. If you do the same thing with mutable data, you're going to have a very big write problem. Because then changing a single street name, for example, will take down your database for the very simple reason that it's copied all over the place. Instead, we've done something very useful for our customers. We've given them the option to have something delivered at their parents, at their friends, maybe even gift wrapped. The advantage for us is that we can simply copy the address data where we want something delivered, copy it to where we want to use it, and because it's become immutable, with the added bonus of a customer-facing feature that we can generate extra revenue from, it helps. It also means why I said if you want to create immutable data, it can change your use cases. It doesn't always mean a bad thing. You can actually make money off of it. Okay.
Makes sense.
Okay.
I see another question.
Over there.
Hi.
Yeah.
You were talking about Postgre only, but
Yes.
do you see any difference in, or major differences if you switch to another database engine?
If it's a relational database engine, it will have the explain command, and the advice actually stays exactly the same. It will even work if you're going to work on big data problems, except that for big data systems, there is usually less of a query planner and executor, and you have to do a lot of this stuff yourself. But, well, that's the easy part about relational databases. They do all this for you.
So there's no real difference that certain databases
No.
are better at something else than others?
Okay. Any other questions from the room? Over there?
Over here.
This is going to be exciting.
Yeah, just throw. It's soft.
Yeah. I was just wondering, so if you would denormalize stuff, for example,
Mhm.
to be able to service that, would you still advise to use a relational database tool? I mean, why not use a document store? Or, I mean, we have other technologies to do these kinds of things as well.
True. The thing is, though, that very often a relational database is more easily integrated. A document store helps, but then you need to be able to denormalize fully. If you still have some relationships, a relational database really is king. And also, if you're not careful, for example, MongoDB usually compared itself to MySQL for the very simple reason that if you put compared it to Postgres, then Postgres would be faster. So yeah, it helps to choose a decent database, but that doesn't necessarily mean that it's a relational database. It's just that relational databases are more widely supported.
Okay. I think we're going to leave it at that. If you could throw the catch box back, don't hit me. Well, maybe. Let's see how this goes. Okay. This is better. Thank you.
Almost.
All right. We're going to switch rooms one more time if you want to. We'll set up the next speaker now. See you back in a bit.